Ciao friends, and welcome to a new Unplugged video. Today I want to show a preview of new features we introduced in DAX Studio. We are introducing in DAX Studio because we see a preview of something that we didn't release at the moment I record this video. We made improvements in the server time in Spain by adding a column called timeline, which replaces the previous waterfall, and we also improved the way we display the X and SQL code of each storage engine query. So let's start with the demo. So this is the coming release. You see that it's a preview of the new release of DAX Studio that is coming soon. Maybe that when you will watch this video, the release is already available. But I'm so excited to show you what we implemented in this new release. So the first improvement is this column that you see here, timeline. You see that this column replaces what was called waterfall, and let's run a query to see what is displaying, what we are displaying in this column. So when we execute a query, we have the classical visualization of a formula engine and storage engine just to quickly understand whether a column is spending more time in the storage engine in a formula or in the formula engine, and this didn't change. However, when did we spend time on the storage engine and on the formula engine during the execution of the query? This is what the timeline column is about. You can see the very same information that you have seen previously in the general information of the query pane in the header. So the header shows the same balance, but this time you have to imagine that you have, at this point, you have 0 time, and imagine that you have a line that represents 100% of the execution time for the query. So it could be 1 minute, it could be just 1 second or 10 milliseconds, it doesn't matter. So this is the entire amount of the execution. Across this line, we can see the individual storage engine queries represented in a graphical way. So yes, you can see the duration in this column, but now you have a more direct visualization of the amount of that duration. And you can see that the difference between 3 and 0, for technical reasons, we show in any case a line, even though the amount is 0, compared to this other storage engine query that is much longer. We can also see in this example that we spent a small amount of time in the formula engine at the end of the execution. We will see that sometimes this is not what is happening, and the formula engine is executed in the middle and between different storage engine queries. So this is a very, very quick way to look at that. And you can also notice another important information. You can see that, for example, in this case, we have a batch execution, which is a request made from the formula engine to a storage engine that includes a number of storage engine queries, but these queries are coordinated by this batch that is executed entirely in the storage engine. So the different color, tonality of the color we have here is there just to highlight the difference that we might have between a batch and the internal scan that are the internal scans that are represented with the italic font in the subclass, because in this case we have to understand that these are the internal events. But now you see the graphical representation, because the duration we have for the batch is only the amount of time spent within the batch that doesn't that is not included in the cost of the internal scans. In this case, it's 0. So basically, the batch acts only as a coordinator and doesn't spend much time. But in other cases, you might see that there is a gap between the internal events, because actually the batch spent some time evaluating the intermediate results. So let's take a quick look at other queries. For example, if I run this query, what happens? You see that I have a different, I'm not interested into describing all the queries, but just want to see, I want to show the different execution scenarios. In this case, we have a simple single scan, but you know that a single scan can have internal events. And for example, in this case, we can see that there are 2 internal events, 2 internal queries that are generated automatically by the VertiPack engine. The first one is generating sort of materialization, but in reality this is not the same level of materialization that we will see in the formula engine, because this materialization is not an uncompressed version of the data. It's just some internal bitmap index usually that we have here. Indeed, if we take a look at the definition of this query, you see that we are extracting basically a list of keys that is used later in the next query to apply a filter. When you see this in B is in a bitmap index. And I'm showing you also a new feature. You see that the visualization of the XM SQL query has been improved. We have a better formatting, we have a syntax highlighting of the XM SQL keywords, and we also have the highlight of the critical information we have in an XM SQL query. For example, in this case, the size of the bitmap index created to filter the customer key has been highlighted in this color. So this way we make it easier to quickly locate the important information that are in the XM SQL query that could be important to understand what is going on. So let's take a look at some other query, because so far we are looking at queries that are mainly consuming storage engine time. Now we see a query that is actually consuming more formula engine time. Look at that, 37% of the time spent in the formula engine, but as you see from the timeline, most of this time is at the end. Even though, well, let's remove the internal, in this case it's not important, you can see that we have two storage engine queries, but we can clearly see that there is a long first storage engine query, some time of formula engine, another storage engine query, and a longer time in the formula engine. Sometimes just looking at that can give you a better idea of what is going on. And then, of course, you can always go to the query plan and see step by step what is happening, but the query plan could be very long. Sometimes this visualization makes it easier to get the big picture of what is going on. As usual, but this didn't change it, we also color highlight the callbacks. In this case, we have a callback that doesn't have an internal DAX code, but in case there is a callback data ID that has DAX code, we also highlight the DAX code that was not happening before. But let's move forward and see some other example that I prepared to show you the feature that we have. And in this example, we have a simple distinct count. If you know, the distinct count internally has internal batches, and I want to show this because in this case it's important to realize that these two internal events in reality are not executed one after the other. They could be just mistake produced by the SQL profiler or two events that happens at the same time. If you take a look at the two events, you can recognize that they are basically the same thing, that only the second one has this estimated size that was not present in the previous one. But the important thing is that you can clearly see that they are executed in parallel. So the begin time and the start time and the end time of these two events is the same. So we don't have to expect that we have to sum those two numbers. It would be pretty much intuitive, but this makes it clear that we are not executing the same internal events twice. So let's move forward to other examples, because in this case we have a bidirectional filter, and the ability to display the batch event in a formatted way makes it much easier to understand what is going on. Let me show you this. So this is the entire batch event. You see that there is a first query, there is a second query, there is an information that is just metadata that does not correspond to another additional internal query that now is separated from the rest. The main difference is that if you look at the same query executed with the previous version of DAX Studio, it could be hard to recognize these statements, because you see just a long list of text, not formatted, not highlighted, and this way we make it easier to spot this kind of declaration that is related to the fact that we enable a bidirectional filter, even though this could happen also for some tree tests and other conditions. But again, this makes it easier to recognize part of the query plan that otherwise will not be immediately visible. I think we have only one or two other examples, and this one to me is very, very interesting. You see, this is another example where the timeline gives us a lot of information. Without looking at the query, I can clearly see from this timeline that I have a long execution in the storage engine, another long evaluation in the formula engine. So I know that when this happens, there is a large materialization that has to be consumed by the formula engine that then prepares a number of other storage engine queries. And you see that we have a longer list of storage engine queries, each one executed for a small amount of time. You see that each one is relatively short, and there is a continuous exchange between the formula engine and the storage engine that takes time, is not efficient. So this is another visualization that make it much easier to understand what is going on. Because imagine that if you only look at this information, you don't get an immediate understanding of what is going on. You might see something when you go to the query plan, but once again, the query plan is just very, 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 very long and does not provide you the same kind of immediate understanding of what is happening in the query plan. I think that this is the last query I have. I just want to show you that this is a query where we are injecting an if statement into a SUMX, and when this happens, we have a call by data ID. As I anticipated before, when we have this situation, I think we can do this, we have the visualization of the callback data ID. What changed is that now the DAX code is part of the syntax highlighting. So we can immediately see which part of the XML query is in reality DAX code executed in a formula engine callback. So this is another information that is very useful and makes it easier and faster to analyze the query plan with DAX Studio. So we have seen that these new features in DAX Studio makes it easier to quickly understand what is going on in a DAX query. A DAX query can have one or more storage engine queries, but we now can see when these queries are executed across the timeline. We can also see when the formula engine is doing its work, and we also have seen that by better highlighting and formatting the XML code, we can quickly understand and spot important information for each storage engine query. I hope that the DAX Studio version we have seen is already available when you watch this video. If it is not, just wait, hopefully just a few days. And in any case, enjoy DAX.